I'm Margaret Bauer. I'm the Lisa Meitner Professor at the Department of Automatic Control in Lund, and I'm also a Professor of Process Automation in Hamburg in Germany.
And my name is Charlotta Johnson, and I'm a professor at the Department of Automatic Control at Lund University. And my research is focused on process control, manufacturing operation, and smart manufacturing. We are at Arilds Vingård, which is a large vineyard here in the southern part of Sweden. And they are also very eco-friendly, and they are working extensively on that part.
The wine production is actually it can be seen as an industrial production process.
So here we have a vineyard, which I would say belongs to the food and beverage sector. Then there are other sectors where control is also an important part, like automotive, for example, pharmaceuticals, for example, chemicals, for example.
Chemicals, yeah, bulk chemicals.
Yes.
Yeah. Metals processing, paper making, the pulp and paper industry also has different aspects of automatic control. So we have the wine making process, and that involves different steps in the production. It involves first crushing and pressing the grapes. But it also involves what we call a continuous process of fermentation. And later on we have a discrete manufacturing process of bottling the wine.
In a continuous production place, the product itself usually stays in one place for a longer period of time, which means from a control perspective that you would like to control a lot of parameters to a steady state level.
In automatic control, you need both a sensor to measure a physical quantity, and you need an actuator. In the process industry, we have two types of actuators. We have valves that you see here, that are manual levers in this case, and we have pumps. And with that, you can control all the different quantities in the process. And the quantities usually are temperatures, their levels, but they can also be flows and they can be pressures.
Then you also have discrete production processes. You have individual pieces, like bottles, for example. And here you would like to start and stop the process. So you would like to play with the logic or sequential control. So from a control perspective, they are very different.
And here at Arilds, it's a comparatively small vineyard. As a result, it's very manual, and that is nice because we can see lots of the operation. If we were going to a bigger site, we wouldn't be able to see many of these processes.
One thing that is a challenge for many of these production plants is that they have equipment, hardware, and they also have software that comes from different vendors. But of course they all should come to play together, and as a basis for that, standards are of importance.
So if my pump breaks down, I can easily replace it with a pump from another vendor because this pump follows the same standards. I can connect it in the same way. We can materialize different ideas by introducing a standard, because some things are not possible if pieces of equipment don't speak to each other. And we see this in industrial production processes where we have valves and sensors that we use to monitor and actuate on the process, and they all have to speak the same language. And that at the moment is defined in a specific standard.
Examples of such standards, I would say, could be the key performance indicators for manufacturing operation management, where different KPIs are being standardized. And the KPIs is a specific parameter that you would like to keep track of. It could, for example, be the availability of a machine or the utilization ratio of a machine. And in order to have a KPI, you need to standardize how it should be measured so that everyone is measuring it in the same way. Sustainability means a lot of different things. It could be about energy effectiveness, and there are standards about that. It could be about CO2 footprints, and there are standards about that. It could be about utilizing the equipment to the highest degree possible. It's interesting here where you have all the vessels or the fermentation tanks, that all of them are attached to these pipes. And this is where they reuse the energy, the heat that is being produced in the vessels. So getting numbers on a lot of parameters can actually help you improve those parameters. And improving them could mean increasing sustainability.
That's the perfect answer. I can't. In one, there's like this. Wow.